Hi guys, this is Abiri. Welcome back to my channel. Do you know Apache Spark 4.2 is released? And let's get one thing straight. This isn't just another release with a handful of new features and performance tweaks, but this is very strategically bringing more of a modern data, analytics, streaming, AI, and spatial stack directly into the engine itself. For years, organizations have relied on multiple tools to handle metrics, CDC processing, vector search, geospatial analytics, and real-time applications. But Spark 4.2 starts collapsing many of these layers into a unified platform. If you are a data engineer or an analytical engineer, maybe a platform architect or a data scientist, or any of you are building in the modern data platforms, this release deserves your attention. So let's break down those into 7 stages of Apache Spark 4.2. Here, the first one starts with the native semantic layer with metric views. This is one of the most impactful additions. Traditionally, business metrics are defined repeatedly across dashboards, reports, notebooks, and BI tools. But one team defines revenue in one way, another team calculates active users. Soon, everyone is arguing about numbers instead of making decisions. So, Spark 4.2 introduces a native semantic layer, metric views. Instead of defining metrics everywhere, you can define them once inside Spark. Business concepts like dimensions, measures, and metrics becomes first-class objects that Spark understands natively. Imagine defining a average revenue per user for one time. Every dashboard, notebook, analyst, and reporting tool can use the same governed definition. This creates a true single source of truth. There are quite some benefits as well. One is like consistent business metrics across the organizations and easier to governance and auditing for those, and it reduces maintenance overhead as well, and faster development of analytics in the teams as well. So Spark is no longer just processing data, it's beginning to understand business meanings. Next, let's talk about one of the most painful areas in modern data engineering: change data cap. Most teams spend countless hours writing complicated merge statements, designing those logics, handling inserts, managing updates, and processing deletes, along with dealing with the duplicates. And the worst of all is handling out of order events. Whereas Spark 4.2 introduces auto CDC for declarative pipelines. SCD Type 1 supports is now built directly into the platform. Instead of writing hundreds of lines of CDC logic, developers simply declare how change events should affect a target. Spark automatically manages updates, deletes, deduplication, ordering, merge processing, data consistency. And the result, with less code, fewer production bugs, faster development cycles, and significantly lower operational complexity. This is a major productivity improvement for teams building modern lakehouse architecture. Next comes the standardized CDC with DSV2. Spark didn't stop there. CDC is getting a second major upgrade. So the data source v2 framework now provides a standardized view for connectors to expose change streams. Historically, every storage system implemented CDC different APIs, different semantics, different operational challenges. In Spark 4.0 introduces a common CDC interface across DSV2 connectors. And here's what things get really exciting. You can now query change streams directly using SQL through the new changes clause. Imagine simply writing a SQL statement to retrieve all changes from a table within a time range. Spark automatically handles net change calculations, deduplication, ordering, tombstone handling, snapshot isolation, internal optimizations. The result is much cleaner. Developer experience a consistent CDC behavior across different storage systems. For organizations operating multiple data platforms, this standardization is incredibly valuable. Now let's shift our attention to streaming and Python. For years, low latency stream processing has often required moving beyond Python to achieve the best performance. Spark 4.2 changes that. A real-time mode is now available directly in PySpark. We are talking about millisecond level end-to-end latency for stateless streaming workload, and developers can control everything using a familiar Python APIs. This opens the door to use cases such as fraud detection, personalized recommendation, real-time monitoring, event-driven applications, future engineering for machine learning, operational alerting systems. Instead of waiting seconds for micro batches, applications can react almost instantly. And Spark's roadmap already includes future support for stateful real-time processing. This makes Spark increasingly attractive for organizations building event-driven architectures. This might be one of the most transformative areas of the releases. Spark is becoming increasingly AI native. Spark 4.2 introduces vector operations directly into SQL. Developers can now perform vector distance calculations, similarity scoring, vector aggregation, and top K ranking joins using nearest by, all directly inside Spark SQL. Why does this matter? Because most modern AI applications depends heavily on vector operations. These capabilities power semantic search, recommendation engines, retrieval, augmented generation, entity matching, customer 360-degree solutions, similarity analysis. Instead of exporting data into separate vector systems, many workloads can now run directly inside Spark. But that's only half the story. Spark 4.2 also introduces native geometry and geography types. Spatial analytics can now be performed using built-in system functions. This enables use cases such as location intelligence, fleet tracking, logistic optimization, geographic analysis, geofencing, store location planning, and the best part, no external extension required. Spatial analytics becomes a native capability of Spark itself. Python optimization Arrow by default. For the Python users, they receive another major boost. There is Arrow optimized Python user-defined functions and now enabled by default. Previously, Python user-defined functions often suffered most from a serialization overhead because data had to move from row by row between the JVM and Python processes. But in Spark 4.2, they automatically uses Arrow's columnar format. The benefits of this are immediate: faster execution, lower memory consumption, reduced CPU usage, better throughput, improved scalability. And here's the best part: existing Python user-defined functions often benefit automatically. No application rewrite, no migration effort, no code changes. Spark also introduces Pandas 3 support and enables zero copy interoperability with ecosystems like Polars, DuckDB through the ROC data interface. This strengthens Spark's position at the center of the modern Python data ecosystem. Finally, let's talk about the improvements analysts have been requesting for over the years. In Spark 4.2, they introduced several highly practical SQL enhancements. First, the qualify clause. This allows developers to filter Windows functions results directly without wrapping queries inside nested subqueries. Cleaner SQL, better readability, and less boilerplate code. Next is the time bucket. In time series analysis, it becomes much easier without complex timestamp manipulation logic. Spark also adds support for SQL cursors and set path, improving workflows, flexibility, and catalog management. For Windows function, developers gain more control through ignore nulls and respect nulls. And finally, Spark introduces top K max by and min by aggregation functions. These functions make ranking and sections, the selection operations dramatically simpler. Individually, these may seem like a small improvements. Collectively, they make SQL development faster, cleaner, and significantly more productive. So the final thoughts for Apache Spark 4.2 isn't just making a Spark faster, it's making Spark smarter. We are seeing platform that increasingly unifies analytics, streaming, AI, machine learning, geospatial processing, and operational workloads under one engine. Metric governance, declarative CDC, standardized change streams, real-time Python processing, vector search, native spatial analytics, arrow acceleration, and modern SQL capabilities. Together, these features reduce complexity while expanding what developers can build directly inside Spark. The result is simpler architecture, fewer moving parts, and a stronger foundation for the next generation of data and AI platforms. And this is one of the most important releases in the recent years. The question is no longer whether Spark can process data. The question is how many parts of your modern data stack Spark can now replace. So thanks for watching and let me know your comments which Spark 4.2 features you most are excited about.